What's up? All right, that's better. Hi, everybody. Just a couple things to be aware of before we get started today. You do have an assignment out. It's due, I believe, 1 week from today. So if you haven't gotten started on that yet, today is actually a pretty low-key day. There's not a whole lot of prep work, not a whole lot of stuff for us to talk about. So, it might be a good chance for you to get started on that assignment or keep working on that assignment if you've already started it. It is due 1 week from today, so let us know how we can help you out with that. Talk to your TAs, talk to me if you need any assistance. Just to give you an idea about what's going on in the next week or so. We're going to keep doing some object-oriented programming stuff today. We're going to do some more on Thursday as well this week, and then Monday is when spring is going to come back. So we'll start doing more spring-oriented stuff again 1 week from today on Monday. So that's kind of where we're headed. I think that's about it in terms of reminders. Are there any questions about upcoming dates, due dates, other assignments, things of that nature before we hop into today's material? All right, so we're going to continue from where we left off last week, actually, with today's material. We covered a lot of ground last Thursday, so there wasn't quite as much ground for us to cover today, but there's still some important stuff for us to talk about, and we'll continue our coding demo that we did in class last week as well. How do we call a method on an object? What's the first thing that we have to do? If I want to call a method on an object, what do I have to do? Step 1. Create the object. Yeah, and I create the object how? Calling the constructor. And once that object gets created, it's called what? Rhymes with Winston's? I don't know. Yeah, that's a tough one. Somebody let me know if you come up with a word that rhymes with instance, because that's what you need. So we need an instance of the object. That's step 1. We create an instance of the object by calling the constructor, right? Step 2. Dot notation. So what comes first? The name of the instance, followed by a dot, and then name of the method, and any inputs that it needs to operate, right? Any inputs that it needs to function. That's it. That's how we call a method on an object, right there. Actually, thinking way back to Unit 1, this is how Python did it too, right? This is how Python had you call methods on objects and create objects as well. It looks a little bit different in Java. The syntax is a little bit different, but the concepts are the same. All right, cool. What is toString? We've seen this before in Python as well. What was it called in Python? str underscore. I don't know how many. Lots of underscores involved, right? Underscore str underscore. So what is it for? If you print something, right, it's going to call the toString method on that object. So whatever you want to see when you print out an object is what you should put in your toString method. If you don't put anything in your toString method, what's going to happen? Does anybody know? Yeah, exactly. It's going to print the memory address where that instance lives. That's exactly right. Which, might be useful, but I'm guessing is probably not going to be useful for you in the vast majority of situations. Where does that come from? Where does that memory address come from? It gets printed out. Or in other words, if your class doesn't have a toString, what toString is it using? Does anybody know? This is a little bit of a sneak preview, actually. I'm sorry? I can't quite hear you. Reference? So that is what you're seeing. You're seeing a reference, the memory address, that is a reference. But if my class doesn't have a toString, right? Where's it going to go look instead? The object class, because in Java, everything is an object. Quite literally. Good. All right. What about equals? Equals, or let's just go ahead and jump right, let's not beat around the bush and just jump right in and talk about what really matters here. What's the difference between equals the method and double equals? What's the difference? Go ahead.
Well, first of all, equals is a method and it's double equals.
That's true, yeah.
The operators are using checks or the actual project itself. And then the equals method, in the ways we use it in like local classes like the trade class, it's reconfigured in a way where it compares content.
Yeah, good. So let's back up a step. You nailed it. So the double equals, you said, compares the references. So for double equals to return true, what does that mean? That means both references have to be the same, which means what? It's the same instance. It's the same instance. Both references are the same, meaning they're both the same memory address, meaning they're both pointing at exactly the same instance of the object in memory. So if double equals returns true, you are looking at the exact same instance on the left side as on the right side. The exact same instance of the object. That's useful, but different from what the equals method does, which checks the actual content of the object. Right? So I'm not looking at the reference, I'm not looking at the memory address. I'm opening up the object and I'm looking inside and saying, does this value of the object equal this value from the object? Does this value from the object equal this value from the object, right? And so which values is it comparing from your objects? The equals method is looking at which fields to check. Whatever ones you want. Whatever ones you want. That's exactly right. Because we get to define what equality means. That actually is a very big power, right? That's a lot of responsibility on your shoulders now to decide what two objects, what it means for two objects to be equal. And if you think about it, you might say, well, what's the point? Aren't I always just going to compare every single field that I have, right? To make sure that things are equal? And the answer is actually no, you may not. You may decide that equality is based on only part of the fields that are involved. In fact, I think we might see an example of that a little bit later on in the coding example that we're going to do today. There might be some fields that don't actually disqualify two objects from being equal, in which case you would decide to leave those out of the equals method. We'll make at least one equals method today, if not multiple equals methods today, and we'll have a discussion about which fields should qualify and which ones shouldn't. All right, last question before we do some coding. What is the single responsibility principle? Mm-hmm. Yeah, so you're exactly right. I call this the you got one job principle, right? You had one job, and you really should be able to look at every method and every class and be able to say, you had one job, and you should be able to say what that job is. If you say that and it's not a complete definition of what that class is supposed to be or what that method is supposed to do, then you might have some things muddled together in your design. Maybe you actually have two classes where you're only actually using one, right? So maybe there's a split that needs to happen, possibly. It can be very tempting to make one class and throw a whole bunch of stuff in it because you don't want your program to get too complicated, right? But you have to remember that classes are an organizational tool as well as a functional tool, and so it's important to make those decisions. Luckily for us, I have been drilling these concepts in your head basically since Unit 1 about what stuff belongs in a class and what stuff doesn't belong in a class. So I'm looking at fields. What's the relationship? Has a. So we talked about student has a name, right? Student has an ID number. That's a quick, easy test that we can use to see if a field belongs in a class. And then for behaviors, which is actually what we're going to be doing for the coding exercise, what's the relationship? What they can do. what the actions can be performed. And so let's go ahead and switch over. We're actually going to continue our course class from before. We're going to continue the course class from before, and what I want to do today is think of some behaviors that we need, right? So I'm going to come down here and make a new set of comments for behaviors below our notes from last week that we would expect a course to be able to do. And this is where I need your help. Who can think of some ideas of things that we would expect our course class to be able to do? Add a student. All right, what else? Grade a student, okay. Now let's say that out loud. Course can grade a student. Does that sound okay? Evaluate. Teacher could do. A teacher can grade a student, right? Or a student can earn a grade, right? So there's some ambiguity there as to where that comes in. In fact, the prep work today, I think, actually had you do some stuff where with the grades with the student class, right? But I think there is a role for the courses and grades to interact with each other as well. In fact, we talked a little bit last time about updating a grade book. We spent some time talking about that last week. So, a course could record a grade for a student, possibly something along those lines. So yeah, I think there's room here for grades to be involved. What else?
If you can add a student, you should be able to drop a student.
Yeah, should be able to drop a student. I agree. What else? Okay, I'll come up with a simple one. Just print the roster, right? You should be able to just get a list of all the people that are in the class. That seems pretty straightforward, right? Any other ones that you guys can think of? I mean, this is fine. There doesn't have to be a whole bunch. I was only looking for a few for us to work on for today. So if this is what we got, then there's some obvious choices here. Adding student, dropping student are pretty obvious choices. And then printing the roster is also a pretty obvious choice. We can make up some others if we have some time and we want to work on some more, but this is good enough to get us started, right? This is good enough to get us to write a little bit of code. So let's go ahead, and the next thing we need to do for each of these methods is decide on a few things, like what? What does each method need? What information does each method need? Access modifier, so is it public or private? What else? Return type and arguments, input parameters, right? So for adding a student, do we have any ideas about those things? Access parameter? I got basically two choices right now. If I mark it private, what does that mean? Only the course class can add a student to the course if I mark it as private. Is that what we want? Probably not. That makes it very less useful to us if it's a private method. We want students to join our class, right? We want them to be able to do that. So it's probably going to be public. What about a return type? Student? Void? Could be void. Anybody have a counter argument? And then what about parameters? Input parameters? Students. So that's where I think we need a student. So I've got these things all out of order. I don't know why I decided to write them down in this particular order, but I did. We'll take care of that later when we actually start writing some code. And then for dropping a student, right? It's going to look very similar, isn't it? Isn't it going to look very similar? Okay, and then what about printing the roster? I'm sorry? The roster? So where's the roster come from? Oh, we did that last time. Yeah? So I have a roster. So do I need any other parameters? No. I got the roster. I don't need any other parameters. So what about the access modifier and the return type? Array list? So this is where I think some naming conventions might help us answer this question. When I say print roster, that literally means I'm just going to display all the information on the screen, right? It doesn't necessarily mean that I'm going to return anything. In fact, any method that says print, I'm kind of expecting the return type to be nothing. I'm expecting it to just show me that information. If I wanted to actually retrieve the roster, then I would say get roster or, get roster string or something along those lines, right? I would actually have a different action associated with the method. But when I see the word print, I'm expecting void here. There will be exceptions, and you can, of course, decide that void is a terrible return type and make it do something different if you want to, because your design does not have to be the same as my design. That's the beauty of designing your own program. But I think void is fine here. And then this should also probably be public as well. So, okay, cool. We can't really do this one or this one until we do this one, right? I can't drop a student if I can't add students. I can't see a roster if I can't put people on the roster, right? So let's go ahead and add a student first. I'm actually going to put it above all these getters and setters. All right, public void add student. Oops. And we said that the input parameter would be a student, and I'll call that student S. Okay. And now I just have to decide how to make this work. So how do I make this work? What do I need to do to add this student to the course? Add them to the roster, right? I need to add them to the roster. So the roster is an array list. The array list was initialized in our constructor, correct? So I just need to grab it. And then I look at my list of things available. Oh, hey, IntelliJ knows what I want to do. It's reading my mind. Add S. Are there any things we need to be careful about here? Any problems that you might see come up from doing things like this? I think if we're very optimistic and perhaps a little naive that this implementation is fine. But if we think about some things that might go wrong, then this implementation might not be good enough. Yeah. Adding the same student multiple times, that's right. So how can I check against that?
See if they're already in the array list.
See if they're already in there. So how do I do that? I can loop through the array list. That was one option. I heard somebody say an if statement. That's another option. Or some combination of the two. Do array lists have a method that could help us here? Let's see. This dot roster dot contains. Here it is. Contains. Passing the student. So we want to add the student if it doesn't contain the student, correct? So I can make an if statement. If not, then we'll add. There we go. That's a little bit safer, right? Otherwise, I'm not sure there's too much trouble here. One situation that you could run into, although we didn't implement it last time, although we could, is if there's not enough space. This happens all the time, right? There's not enough space left. We did not create that variable for a number of seats involved. But you could see how that might look. It'd probably be another if statement check. If there are enough available spots, then you can put the student in the class. If not, then I'm sorry. And actually, both of these situations have me thinking about maybe adjusting our design just a little bit. We have a void return type right now, but since it's possible that the student doesn't get added, I think it might be smart to change this to what? A message, so a string? I was thinking of something a little bit simpler, but you could do a string. What about just a Boolean? Yeah. Did they successfully get added to the course or not? Right? Did they successfully get added to the course or did they not? So, we'd have to update our method to indicate that fact. So here I would say return true. And then if they made it through, or if they didn't get to go into the if statement, then I returned false, right? Just to indicate to whoever tried to add this student whether or not they actually got added. Because that's something that the student would probably want to know, correct? Correct? Is it 100% necessary? No, maybe not. But something that we can do. Tweak our design a little bit. Okay. What about dropping students? So let's do that. Public. So we had void listed here, right? And that might be okay. Drop students. We decided that the parameter was going to be student S. Kind of a similar thing, huh?
Yeah, first you need to see if the student's in the roster.
So if the student, so that's the question, right? If the student is not in the class and they try to drop the class, what would happen? And so how are we actually going to take the student off the roster? Is there a remove method? Let's see. This dot roster dot, there is a remove method, right? So my question is, all right, what happens then if I try to do this, but S is not on the list? Is it going to cause an error? Is it going to not cause an error? Are we, is my computer going to blow up? Right? I actually don't know, but I know where to find out. Our good friend, the Java API. So let's look up array list, Java. And I want the Oracle docs. That's the official Java documentation. So array list, the documentation is kind of long, but the good news is that we know what we're looking for. I'm just interested in removing stuff. So let me zoom in here so you guys can read what's going on. So I can just scroll down the list. You see all the methods here. I just care about removing stuff. So I'm going to go ahead and say remove, right? So removes the first occurrence of the specified element if it is present. If the list does not contain the element, it is unchanged, meaning that if we call remove and the student's not in there, then nothing happens, which is actually fine, right? It's actually fine. But here is something interesting. It's telling us, right, how it decides whether the object is in the list or not. And here is something that we've been talking about. The equals method. How does it know if it's actually in there or not? I think actually if we look at another method that we've been talking about today, contains, right? Oh, hey, there it is again. The equals method. It's using the equals method of the object to decide whether it is in the list or not, whether it can remove that thing or not. And we don't have an equals method, at least not yet. But let's do that. Let's decide what equality means for a student. In order to do that, we're going to go back to our student class, and I'm going to look at the fields that I have available, and I need to decide, right? Of the fields that are here, which of these fields define equality? The student ID. Okay, what else? Crickets? Yeah. So if I didn't change the equals method, you're right, they would have to be identical. My question to you is that what we want? Or do we want, what of the fields do we want to be in our equals method? Because we have the power to change that. So right now I've heard student ID is one thing that we should use to determine equality. What else? Number of credits? Oh, you're getting voted down, man. I'm sorry. It wasn't my call, but actually I would vote against you too. No hard feelings. No hard feelings. Name is not necessarily good enough, right? Because people can change their names.
Or it could be two of the same.
There could be two people with the same name, yeah, but they aren't the same people. Exactly. GPA, number of credits. What if I have an old record somewhere from, the student from last semester and try to compare it to the student against this semester? Their GPA, number of credits, is going to be a little bit different, but they're the same student, right? So the equality that we're really concerned with here, I think, is the student ID, and that's it. Here's an example of, not every field is necessary to determine the equality of two objects. Now, here's another tip. I can't remember the last time that I actually wrote an equals method myself. Just like we saw last time with the getters and setters, most tools, most IDEs are going to provide a way to create an equals method for you because they all kind of follow the same standard formula. So I hope you wrote the equals method, as part of the prep work, just to do it a few times. Everybody should do it at least a few times, I think, just to get a feel for what's going on. But once you understand it, once you understand what the equals method is doing, understand the formula that it's spelling out, you don't have to write it anymore. You can ask the IDE to help you out with that. So just like I did last time, I'm going to right-click. I'm going to go up to Code and then Generate. And then here we go, equals and its friend hash code. They go hand in hand. They go hand in hand, although the prep work I don't think really talked too much about hash code. Does anybody know, just offhand, what hash code is used for? We talked about hashing before, right? Hash map, so yeah, hash map. But in general, more general, what's hashing used for? We used it with security before, right? Shorthand identifiers. So it allows me to take an object and turn it into a number, and then I can compare those two numbers, and if the two numbers are the same, then those two objects are likely the same. In other words, it's using a hash function to help it decide whether two objects are the same or not. Not encryption necessarily, but hashing is used for encryption as well. Yeah. I don't know if it's necessarily more thorough or not, but what it is efficient because I can very quickly compute a hash and then check to see if those two numbers are equal. So I don't necessarily need to go through every single field of an object and compare them one at a time if I have the hash. The equals and hash code go hand in hand because oftentimes you'll see the equals method call the hash as part of its functionality. In fact, I think that's what we'll see here. But let's go ahead and create them and then we can take a look at them and see exactly what's going on. So I'm going to hit next, and now here's a screen that's saying, all right, which of the fields do you want to use to determine equality? And we already talked about this. We decided that student ID is the one that we want. So I'm going to uncheck everything except for student ID. And then I'm going to hit next. All right. So here we have it's actually asking us about hash code now, and it's choosing the same ones that we used for equals, which is almost always what you're going to want to do. So I'm going to hit finish. And now I see here's my equals method. It might look a little bit different than the one that is prescribed in the prep work, but it's more or less the same. It actually doesn't call hash code, so I was a little bit off on that one. I thought it might, but it actually didn't. But here you see it does reference student ID. So it's checking to see if the class is the same, right? And then it's comparing the student ID. And if they're the same, it's saying, yes, it's the same thing. If they're not, then it's saying, no, this is not the same thing. Hash code, you can see, is just hashing the student ID. Okay? You often will not see one without the other. You will almost always see equals and hash code go together hand in hand. Hash code is used actually with hash maps, since you brought up hash maps. When a hash map, we're getting a little bit off the beaten path here, but when a hash map hashes an object to put it into the hash map, what does it use? It uses hash code. So if you have a really bad hashing function here, everything's going to hash to the same thing, and it's not going to work very well. But we're just letting Java do the hashing for us, so it should be okay. Of the two, I care a lot more about equals than about hash code, at least right now. But does anybody have any questions? I know I kind of threw a bonus hash code in there, even though it wasn't talked about a whole lot in the prep work. Anybody have any questions? Okay, so we have our equals method. And again, to put this all back in perspective, the reason that we took the time to make our equals method, which actually I'm just gonna move them because it's bottom here. Sorry. Chose a bad spot to insert them. All right. Which, by the way, we could talk about Java style a little bit, right? Fields usually at the top of your class, followed by constructors, followed by other methods that you care about, followed by standard methods that you would expect to see often in many classes, like equals. Actually, I should have put them, I should have put them here. Followed by getters and setters. I tack getters and setters on the end because they're usually so simple that I don't care. I don't want to look at them, right? I don't need to. I understand what a getter and setter is. I'm just going to throw those on the end. So we're trying to keep the important stuff up towards the top. What are the fields? How do I create this thing? What are the methods that I can use on this object? Anything that's, you know, kind of standard, kind of repetitive, toString equals hash code, getters and setters, shove those to the bottom of your classes. Keep them out of the way. Java doesn't enforce that, of course, but that's pretty standard. And so the reason that we took that whole detour to do equals again was so that things like remove and contains would work properly, would work the way that we expect. All right, good. That was a long tangent, but thank you for coming along on that ride with me. The last thing that we need to do, and then we'll start testing some stuff, is a print roster. Print roster. All right, cool. So I want to print out every student on the roster so I can see them, right? Public void print roster. We decided there didn't need to be any inputs. So how am I going to print out the roster? What do I need to do if I'm going to print out every student that I've got in the class? It's probably a good time to use a loop. Yeah, use a loop. So 2 different ways we could do this. 2 different kinds of loops we can write. Doesn't really matter to me which one you do. I less than this dot roster dot size. Oops. And then I can just print out, oops, this dot roster dot get I. Oh, 2 main parentheses. So when I say this dot roster dot get I, what is that doing? Grabbing the student at that index, yeah. And then I print out that student, which does what? When I print out the student, what happens though? toString, it calls toString. I don't have a toString right now in my student class, do I? So it's going to call the one from the object class, which is the memory address. In fact, let's test it and see that that happens, and then we'll fix it. It is going to be a little bit of a problem, but let's test it, and then we'll fix it. So I'm going to create a course. I'm going to create a couple students, and then I'm going to add them to the course, and then I'll print out the roster. That's my goal, right? All right. I need a main method. If I'm going to run a program, I need a main method, so I'll go ahead and stick a main method in here. All right, so I need a course. So we need to call the course constructor. Course LC101 equals new course. And then what information does it want? It wants the course name and the course number. So what's, it's called launch code, I guess. And then the course number is LC101, right? All right, so now I have a course. Let's create at least a couple of students. Student S equals new student. And then I have to provide what? I mean, actually, student has a number of constructors, correct? And I can use any one that I want. So if I want to keep it simple, I could just pass in a name and let it choose a student ID, right? If I want to keep it simple, I can do it that way. Or I can pass in a whole bunch of stuff if I want to customize that student, right? But let's keep it simple. I just need to give it a name, so let's give it a name. I don't know, Keanu Reeves. And let's make another student. Oops. who else is in this class? The guy that Keanu Reeves was in the Matrix.
The gal.
Trinity. What was her name? Her name was Lawrence Fishburne was in the Matrix. Carrie, what was her name? Carrie Moss. Thank you. Yeah, I got to do that now because I'm gonna feel bad if I don't. Sorry. Is it Carrie or Carrie Ann? I don't know how to spell it. Ann? That's not right. Just Carrie? Okay. Carrie Moss, whatever. I hope she's not watching this video. Very mad at me. She's never gonna talk to me again. If you are watching, I'm sorry. All right. Now we need to add them to the course, right? So let's do that next. So if I want to add them to the course, what do I need to start typing? Name of the course. So LC101 is where I've got my course instance, right? And now I hit dot, and actually, hey, look, there's that list of stuff again, right? So IntelliJ is smart enough to look at what's in my class and provide me an update list of what's available. Here's what I'm looking for. Add student. LC101 dot add student S2. All right, cool. And then I want to print out the roster. So LC101 dot print roster. Great. We created LC101. We added some people, and now we're going to print out the roster. And notice, remember, we don't have a toString in our student class. So when I print out the roster, I'm not expecting pleasant things to happen, but we'll fix that once we verify that the other things are working as we expect. There we go. So it tells me what it is and then a memory address, which those are very low memory addresses actually. 20, 21, 22. Maybe I should go play the lottery after this. But I want to fix this. So in order to fix this, I need to implement the toString method of my student class. So we can go over here and do that. Right. Public. So all toString methods are going to look the same. The return type is going to be string, toString. And the input parameter is going to be any input parameters? No, nothing. All toString methods are going to look like this. They're all going to look like that. And then my job is to return a string with the information that I care about. It's a similar question to the equals, right? If I print out a student, what information do I want to see? I might want to see all of the fields, or I might just want to see some of them. It's up to me as the programmer to decide what is important to me and print that information out. I think we should print out, well, I don't know. It's not up to me. You guys get to decide. What do you think we should print out? The name? Okay, what else? Student ID, all right. Anybody want to lobby for another one? Number of credits? I mean, we can do as many or as few as you would like, right? Do all of them? Okay, you're making me work for it. That's fine. Return name plus this dot name. What was the next one? ID. Oh, I need a space there, probably. Plus this dot student ID plus credits plus this dot credits plus, oops, it's not credits, is it number of credits? Thank you. Plus GPA plus this dot GPA. Most toStrings are also going to follow this format, right? A label followed by the value. Label, value, label, value. They're almost always going to follow this format. It's pretty standard. And so now that I've got this rather long toString method, I should be able to run this again, and hopefully we should see some meaningful information. instead of the memory address. There we go, nice, looks a lot better. There's the name and the ID numbers. You can see the ID numbers are counting up just like we wanted them to. That looks good. They're not doing very well so far. That'll change because Neo can dodge bullets. All right. Cool. Does anybody have any questions or anything else that you would like to talk about while we're messing around with some objects? This is where I had planned to stop for the day. But just a quick little recap. Hopefully I convinced you of the importance of toString equals and kind of hash code, although we didn't get into hash code too much, but toString and equals, very, very important, right? We use them both when we were implementing the behaviors that we wanted to see for the course class. And then in Studio today, you're going to revisit the Studio that you did last Thursday and write some methods for the menu for the restaurant that we were talking about in class last Thursday. So any questions? Yeah, what's up? So where to place your main method? Sure. Yeah. Well, so here's the thing about main methods, right? Is that I can have as many of them as I want to. I can only have one per class, right? But I actually like to stick a main method in a class to help me test that class. Just a little small local test for that class to print out some stuff and make sure that that class is working. So if I wanted to put another main method in my student class to test some stuff about what the student class is doing, I could put another main method in here, right? And so then what a lot of people might suggest is that for your program as a whole, you're probably going to want to separate your main method off into its own, just keep it by itself. You'll see that happen a lot. Yeah, but I am certainly in favor of putting in additional main methods to test your code at various points. Just quick little tests that you can run to see that things are working before you move on, because testing is very important. Very, very important. Yeah, what's up?
Can I ask this on the slide?
Sure.
Are there best practices regarding when to put this dot?
This dot? So I try to put it anywhere that I can. That's my personal preference. The main reason being that it really helps, I think being explicit helps understandability and readability of your code. It's not strictly necessary though, right? There are times when it is strictly necessary. If I have two variables with the same name, then I have to use this to distinguish which one I'm talking about. If I'm referring to a field, I have to use this. But I really prefer to include it. There's two forces at work in your code that are kind of at conflict with each other. There's readability and then there's brevity. So you don't want to write a novel necessarily, but you also want your code to be understandable. So it's kind of finding a sweet spot, right? I don't need 100 lines for every single thing that I'm doing, but I do want to show enough so that if somebody else is looking at this, they'll be able to quickly and easily pick up what I'm trying to do. And so, this dot is 5 extra characters. I know it's extra work, but I prefer it for the sake of readability. If you disagree with me, then you don't have to. I think some people would tell you that they never type it and they get along just fine. Yeah.
What the information that you're conveying there is that an instance method, not a static.
An instance, or just a field. Yeah, just a field. I mean, that's what this one's doing. Yeah, although you can use this to call methods as well, right? And I think that I would still continue to use this. Again, I try to use this anywhere that I possibly can for the sake of readability. So the counter argument is like, okay, if I take it off and I see, well, name is still purple, so somebody still knows that that's a field, right? Well, what if somebody's not looking at your code in IntelliJ? What if they're looking at it in some other tool that doesn't have all the fancy stuff that IntelliJ does? Then I would still want that person to also be able to look at that and know that I'm talking about a field. And so this is a very clear indicator that, hey, I'm talking about a field here. This isn't just some random variable. I'm talking about a class level field variable. Because, you know, we can't expect everybody to have purple variable names for these kinds of things. Yep. Actually, I used to work with somebody who was red-green colorblind, and so the syntax highlighting stuff was just almost useless for that person. So another reason to consider not leaning on, the colors are great, right? I'm not saying you shouldn't use them, but don't lean on them because you never know what somebody else is going to have or not have. Any other questions that I can answer for you all? All right, that's going to wrap it up for now. You've got a studio to work on. You've also got Tech Jobs MVC to work on. So use your time in whatever way makes the most sense to you. Let us know how we can help you accomplish your goals, and we will regroup at 8 o'clock as we usually do to chat about today's studio. I'll see you then.
Hi, Doug.